sequence a sub n such that for each k and n there's a subsequence converging to 1 over k, but there isn't a subsequence which converges to 0. So I want to talk through a little bit about why that's not possible. In particular, I want to show you that if you have a sequence that has subsequences converging to 1 over k for every single k, then you must be able to construct a subsequence that converges to 0. In particular, I want to show the following. I want to build a new subsequence of our sequence so that the kth term is within 2 over k of 0. And I'm going to do that by picking a term within 1 over k of 1 over k. So for the first term, it should be within 2 of 0 by picking it within 1 of 1. The second term will be within 1 of 0 by picking it within 1/2 of 1/2. The third term is within 2/3 of 0 by picking it within 1/3 of 1/3, and so forth. So just for this toy example, I built a sequence, and it has subsequences that converge to 1, 1/2, 1/3, and 1/4. Right? Our real sequence that we're talking about this problem also has subsequences that would converge to 1/5 and 1/6 and 1/7 and 1/8 and so forth. So I'm just doing a sort of a basic example that doesn't fulfill everything just to kind of motivate this. And so I have this subsequence that converges to 1. In particular, that's this blue subsequence. So if I look at those blue terms as I go further and further out, I can see that that subsequence converges to 1. I also have a subsequence that converges to 1/2. Those are my green terms. I have a subsequence that converges to 1/3. That's my purple terms. And I have a subsequence that converges to 1/5. That's my black terms. And again, in the sequence that we talked about in the problem, it would also have more subsequences that converge to 1 over k for every single k. And so using this, I want to construct this new subsequence. And so my first term should be within 2 of 0 by making it within 1 of 1. So if I'm within 1 of 1, I have to be between 0 and 2. And I know, right, I'm letting epsilon equal 1 here. I know there exists a point where all of my terms were going to be within 1 of 1. In fact, they're always within 1 of 1. And so I can pick any of those terms in that blue region that are within 1 of 1 to be into my new subsequence. So I just pick one of those terms. Now, I also have this subsequence that converges to 1/2, which means at some point I can get it to be within 1/2 of 1/2, or I can get the overall terms between 0 and 1. And again, I'm picking that epsilon of 1/2 because then my epsilon neighborhood will go all the way down towards 0. And so I can pick a term, again, that's going to be now between 0 and 1, so it has to be within 1 of 0. And so I pick this red term here that I'm highlighting. I can pick any of those terms that are in that green highlighted area, as long as they're to the right of the other red term that I've already picked. Now, using the subsequence that converges to 1/3, that purple subsequence, I can make it within 1/3 of 1/3, so I can always make it between 0 and 2/3, which again means I can pick a point in this purple region. Now, I can't pick this point that I'm clicking on, because then that's to the left of the red point I've already chosen, so that wouldn't be a proper subsequence because we can't have the terms be out of order from the original sequence. But I know there's infinitely many terms in this purple region, so I'm allowed to pick one that's just to the right of the things I've already chosen. So maybe I pick this term down here, this one I'm highlighting in red, and throw that into my new subsequence. Again, I move one step forward. I know that there's a subsequence converging to 1/4, so there must be, I can get it within 1/4 of 1/4, so between 0 and 1/2. And so again, there's a bunch of points in that region. There's infinitely many. So I just pick one to the right of everything I've chosen before. And in this way, I'm building this new subsequence where the kth term is within 2 over k of 0. And then I can use a little epsilon argument to show that if a sequence satisfies the fact that the kth term is within 2 over k of 0, then it must converge to 0. So you just let epsilon equal be greater than 0, and then you're going to just show which term you need to pick to be within epsilon of 0. So you can do out that argument. Hope this helps.